Hey everybody, we are going to go over section 5 today where we're talking about adding and subtracting rational expressions. Remember, rational just looks like a fraction. So remember, to add or subtract fractions or rational expressions, you must have a common denominator. Okay, so hopefully this looks familiar to you, right? In order to add these fractions here, 1/4 plus 2/4, it's important that we look at the denominators. 4 and 4 both on the denominator, so we keep the denominator and then we add the top. 1 plus 2 is 3. So for example, let's just say we don't know exactly what the denominator is. We're going to look here. Are the denominators the same? Yes, they are. So we're going to keep the denominator. And then we're going to add across the top. Okay? Same thing with subtracting. We're going to check those denominators. So 3 and 3 on the bottom, which means we keep the 3 on the bottom. And then we're going to subtract across the top. 7 minus 2 is 5. Same thing here. If we don't know, before we subtract them, we have to make sure we have a common denominator, which we do. We keep the C in the denominator, and then we subtract across the top. Okay, so hopefully that looks familiar. Let's see if we use the same idea for rational expressions. So again, always when we're adding or subtracting, we have to make sure there's common denominators. That's not the case for multiplication and division. We have the same common denominator here, so we're good to go. And now we just look at the top. 7 plus 3 is 10. We need to simplify this. We can simplify by dividing both top and bottom by 2. And we end up with 5 on the top and 2x on the bottom, which that's perfect. And then looking here, we want to make sure, okay, do we have the same denominator before we add or subtract? The answer is yes. The denominator stays x plus 6, and now we're going to subtract across the top. Nothing to simplify here, and we're done. Okay, hopefully that looks familiar. But what if the denominators aren't common? Okay, so remember, what would we do if it was a fraction? Well, if I had 4/3 plus 5/6, we would look at the denominators first. If they're not common, we're going to look at them and say, okay, what can I multiply to make sure that we have a common denominator, or an idea, the word for this is the least common multiple. What can 3 and 6 both become without getting too big? And I know 3 and 6 can both become a 6, right? So 6 is going to stay the way it is, but this 3 needs to multiply by 2. So we're going to multiply it on the top and the bottom here, right? So whenever I multiply something to the top, I'd have to do it to the bottom and vice versa. So I end up with 8/6 plus 5/6. Now we have denominators are the same. And now we just add across the top. 8 plus 5 is 13. And now that we're in Algebra 2, we just leave them as improper fractions. So this idea of a least common multiple, sometimes it gets more complicated and we can't quite do that in our brains. So how would we find a least common multiple? So first one, we're going to factor as a product of primes. So let's factor 27 down. Let's just see. So I know 3 and 9 can make 27. This is a prime, so that's done. Let's make these into primes. So I see, basically this is 3 to the 3rd power. 81 can be written as 9 times 9, which breaks down to 3 times 3 and 3 times 3. So I'm left with this many. We're going to multiply each factor. Basically, we're looking to see, okay, what's the LCM? The LCM is we're going to multiply by the number of factors that occur in either. So because they both have 3's, right? The number that's the biggest is this one. So they can both become 3 to the 4th because this is the biggest number that the 3 occurs, and 3 to the 4th is 81. So I know the least common multiple of both of these is 81. So I would just have to multiply the 27 to a 3 to get another 81. So how would you find a least common multiple of these here? So the same idea. We're going to factor these down as a product of primes. So remember, if we factor we always look at your graphing organizer. We're going to look for GCF. So let's look at this. 4 and 16, I can pull out a 4. And I'm left with x squared minus 4. I can factor what's left inside here, and I get x minus 2, x plus 2, because those are a difference of 2 squares. So that's completely factored down. Now we can move on to this other one. So again, I'm going to pull out a GCF. I see 6, 24, and 24. I can pull out a 6. I'm left with x squared minus 4x plus 4. And if I factor this, this is a 3 term, so we're going to try to use x factoring. What multiplies to 4 and adds to negative 4? Well, how about negative 2 and negative 2? So I end up with this 6 stays the same, and now I'm factoring these. And I end up with x minus 2 times x minus 2. So now we're going to look to see, okay, what factors happen in both of them? And we're going to multiply each of them by what happens. So the LCM, we're going to go 4 and 6. We see negative x minus 2 in both sides, but we're going to pick the one that happens the most. So x minus 2 squared, and then we're also going to bring down this x plus 2. So this is the total least common multiple that we're going to need to make our common denominator for, okay? So now if we're going to add it to these unlike denominators. So here, this can't factor down anymore, but this one can. Let's pull out a GCF of 3x, and we end up with x plus 1. This here we can factor down to 3 times x times x. So we see here, we see 3x for both of these. So the LCM is going to be 3x for both of them. And then whatever's left, we also bring down. So we've got an x here and an x plus 1. And that's our total LCM. So this is going to be 3x squared times x plus 1. So we're going to use this to get the denominator to be the same on both. So I see 9x squared is here, and I need there to be, oh, actually this needs to be another 3. So this is going to be a 9x squared actually. So now we're going to figure out what do I need to get on both of the denominators to make these common. So I'm going to multiply this one by x plus 1 on the top and the bottom. And this one, I'm just going to need to multiply by 3, because when I factored it, I got 3x times x plus 1. So I need another 3, and another x, because I want it to be 9x squared. So I'm going to multiply both top and bottom by 3x. So I'm left with here, I get 7 times x plus 1 all over 9x squared times x plus 1, plus this here is 9x squared all over 9x squared times x plus 1. Now we have the same denominators, so we're left with, on the bottom, 9x squared plus 1, and on the top, if I distribute this out, I get 7x plus 7 plus 9x squared. And I can simplify this 9x squared plus 7x plus 7 all over 9x squared times x plus 1, and that is it. Okay, what's a complex fraction? So a complex fraction is when we have basically fractions within fractions. Okay, so just keep in mind when we deal with complex fractions, we're going to break them up into the numerator of the complex fraction and the denominator of the complex fraction. Anytime there's multiple fractions within a fraction, we're going to take care of them first. So we're going to give this one some special attention. So let's just pull this one over, and we're going to deal with this one first. So if I've got 1 over x plus 4 plus 2x, I know if I'm going to condense this down to one fraction, I have to add 2 fractions, which means I need to find a common denominator. I see here, in order to make these the same, I need to multiply this side by an x and this side by x plus 4. So I'm left with now x over x times x plus 4, you can leave it factored, and 2 times x plus 4 all over x times x plus 4. And we're left with the same denominator, so these are identical. This becomes x times x plus 4 on the bottom, and the top is just x plus this. So we go x plus, and I can distribute this right now, so that's 2x plus 8. And if we're going to simplify this, this becomes 3x plus 8 all over x times x plus 4. Okay, now remember, that is just replacing the denominator here. So if we rewrite this, and in the numerator, we still have 5 over x plus 4 all over 3x plus 8 all over x times x plus 4. Now keep in mind, remember when we have a fraction divided by a fraction, we're going to multiply by the reciprocal. So I'm going to move this down right here. So we're going to multiply by the reciprocal of the second fraction. And now we're just multiplying, which we remember we can cancel like terms. So see how these are both being multiplied, so I can cancel these out. And now I'm left with 5x on the top over 3x plus 8. And now we're done. All right, I'll see you in class.